may need it for future reference. So allow me to share my screen so that we start our discussion for today. Yeah, I want us to discuss about software design and the software design being one of the stages that any software has to go through if it is to be a successful project. So in this case, software design and software engineering are like related. You cannot separate the two. So in our case, we are going to be, of course, looking at what we call the architecture design decisions, architecture views, the styles and partners, data-centered architectures, and so on as you can see them. But of course, not forgetting that, yes, at the end, we shall have some bit of exercise, which will be, of course, based on what we have discussed. Yeah, and then what I'm expecting is that at least everyone at the end of this lecture should be able to introduce architecture design and to discuss its use. Then also the design decisions that have to be made, as well as the three complementary architecture style covering, of course, organization, decomposition, as well as control. So now, here we look at the various multiple variants of software design, where the focus will be on function-oriented design, the object-oriented design, data structure-centered design, as well as component-based design. They are designs which are function-oriented. They are already structured in nature. And then we have what we call the object-oriented designs, you get. Then we also have what we call the data structure-centered design, and those which are specifically component-based designs, you get. Yeah, they are simple because now as you hear the word function-oriented or those which are structure design, they are based on divide and conquer strategy, whereby the issue is to conceptualize the problem into several well-organized elements of solution. You get, yeah. So you don't take a real problem as a wall, but instead you divide it into several well-organized elements. You say that, okay, if there is a problem with the thing.
I was deep asleep.
Request that when you join us, please you mute so that we can have seamless kind of interaction. Yeah, thank you. Then I was telling you that for function-oriented, we basically look at conceptualizing the problem into several well-organized elements, you know. Yeah, so we arrange our solution into small, manageable kind of solutions, you get. Meaning that each small problem is individually solved until the whole problem is solved. Because now you may have a system whereby maybe the system is being challenged with what we can call maybe with so many loopholes. Yeah, these loopholes can be maybe in terms of they can be in terms of maybe right? Yeah, but then that several what? Several components. So then you decide to either first work on maybe the issue could be coming from it could be coming from login or sign up, Yeah, sometimes it can be on maybe on a way of I request that whoever joins, please you mute. I don't want to mention names, but kindly allow and so that we can have better kind of interaction. So I was saying that the small problem are solved by means of solution modules. Yes, like it is we call nested. Oh, if I can share with you here. Mwesigwa, like we had agreed that when you join, you mute, but you have not done so. It's the same as Otis, Zander. Please mute your device. Then, okay, Zulaika, thank you for doing that. Can you please mute your device, Zulaika? Okay. I don't know what is wrong. When I mute you, please respect and don't unmute immediately, unless you have something to say, but still you have to put up the hand, then we can give you a go ahead. Yeah. So I was saying that let me share with you some bit of function-oriented kind of design. Yeah, but I'm going to just show you modules to show you that okay, like a big problem can be separated into small, well-organized kind of solutions in the form of modules, right? Yeah, then it is upon that you get to know how best you can provide the solutions. Yeah. Okay, okay. Yeah, we can have something like the LCWG. Yes. Now here we are. We have to this kind of, let's assume, this was generated out of a problem that was existing. Yeah, whereby maybe people could not, like maybe easily apply for courses at our campus. So maybe issues were raised and then a solution was done, what was proposed. Yeah. Then what we can do is now you see that we have a module called apply online or online application you get. So, and when you go to it, of course, you see that it is an independent module, which has redirected us to what? To admissions.umu.ac.ug, where you have to do what? To sign up. You get that is in case you don't have an account with this system. If you already have one, then you just log in and then proceed to do what? Of course, to apply. You get. So, but that does not mean that it is the only one. The only one. Yeah, because sometimes someone may be interested in courses, maybe. So you realize that there are quite a number of modules, meaning that the problem that was existing was approached or it was designed in was designed in what we call the function-oriented, or what you can call the structured design. You get. And these modules are arranged in a hierarchy, they communicate with each other, especially these days. Yeah, this can be done through APIs whereby each is interlinked to the other, because now, as you can see, yes, of course, we are on the main, which is UMU.S.UG, but when we clicked on apply online, we were redirected to subdomain called what? Admissions.umu.s.ug. Yes, this subdomain can be at the beginning, it can be forward slash, whatever, depending on how you configure your domain. So whatever happens here has to be sent at the back end of this main system to ensure that, okay, on a return, you get all what you need, and then all will be in place. Just a moment. Moment. Machine. Okay. Right. Is there a way of the specifications? Specifications. Okay. Okay. Sorry for some disruptions. Okay. Function-oriented design, whereby its process, you realize that the whole system is seen as how data flows in the system by, of course, data flow diagrams in most cases. Yeah, it is what we use. So these data flow diagrams, they can depict how functions change data and state of the entire system. We have been telling you that, okay, when you come to apply online at UMU, yes, you are going to, of course, if you're a new user, we shall, of course, start with sign up. You get. If you're existing user, then you will, of course, go straight to login. And once your details are real, authenticated, then you will be directed to the what? The application form, where you have to fill in. Then after maybe completing the form, then you have to go to pay. Once payment is done, then you can probably submit, depending on how the user requirements are are determined. You get. So the entire system is logically broken down into smaller units known as functions on the basis of their operation in the system. So each function is then described at large. You get, yeah, it is a very good kind of, process design whereby you get to manage each function, because now, like I've just told you, now, like this function, we are specifically on what? On applying online. You get, meaning that you put all the focus on what? On online application. Yes, it does not mean that our system only does that, but we are trying to see, we are designing, we are designing, we are putting all our efforts on what we call online application. So all the designs we are making are specifically for that function, what? Online application. Uh, uh, then we have what we call object-oriented design. And you realize that software design process can be perceived as a series of well-defined steps. Yes. And you realize that they evolve, of course, according to the design approach, which can be function-oriented or object-oriented. And in most cases, it may as well, it has to go through the following what? The following steps. So a solution design is created from the requirements of previous used systems. Yeah, now here, when I say a solution design is created from requirement, yeah, meaning that when you get the requirements, that is why actually we are doing the design after system, after requirements gathering. Yes, it is from these requirements that you're going to come up with designs you get. So now you can create your design that is from requirements in case the system, in most cases when the system is new, you get. Or you can as well create your design basing on the benchmark C. Yes. For example, if like maybe for us, we say, okay, previously maybe we did have online application as OMO, but then we say, you know what, how does Cambridge do their online registration or application? You get it. So we look at the previous USB systems, you get it. Then we come up with a design. We say that, okay, when you go to Cambridge University or you Cambridge University portal, you realize that when you go to click on apply online, they first, bring you the sign up. After sign up, then you are given a form. After a form is being filled, you can submit. But then after submission, this form is going to be pending until the payment is made. And then once the payment is made, which payment gateways are you going to be using on this kind of, system? Is it mobile money? Is it bank? Okay. What do you need to pay? Is it, like maybe you have a token number, you can maybe have a reference number that you can use, whereby now if we have the bank APIs, that means that whatever reference number our system generates, it is tied to the applicant is what? The applicant's name, whereby at the form, whereby the moment you take this reference number to the bank and pay, that credit is going to be posted onto your account or the names of the applicant. Then the system will automatically do what? Make the system status change from pending to maybe submitted or complete. You get. So objects are identified and grouped into classes on behalf of similarity and so on. So software design is core activity of software engineering that you cannot miss. It is a must that you have to do it. You have to, of course, come up with the designs before you can actually go to other steps. Once you have the requirements in place, it is applied regardless of software process model. Either you are using waterfall model, you are using spiral model, you are using XP, whatever. It is mandatory, it is advisable that you have to carry out what we call what? Software design. Once software requirements have been analyzed and specified, software design is the first of the technical activities that you have to do. You have to, of course, undertake here, where you have design, the code generation, and testing. So each activity transforms information and results in validated computer software. Yes, like from requirements. So allow me to ask again, if the whole devices are not muted, please help me and mute so that in case you have anything to say, you put up your hand and then we can do it. We can give you a go ahead and we move. Yes, thank you. So we have software design models where we have for designs, that is the data, sometimes referred to as class design, architecture, the interface design, as well as the component design. We can look at them. Now here we have the analysis model, then the design model, whereby these are always, followed. that is for proper implementation of the designs. Then when you come here, what we call the data design, it's of course created by transforming the analysis model into classes and data structures. So we have the architecture. Actually, we have this. We have this in our next chapter, and they are well elaborated in a more practical way. Architecture design, this one basically defines the relationships among the major structural elements of the system. Yes, yeah. Once you have for the different structure elements of the system, what highlights or what brings out the relationship among them is the architecture design, how the different components are going to relate. Then it is the specification. Yeah, like of course, you know very well before we design, those requirements have to be in place, and then it is from those that we generate our design. So when we talk about the interface design, this is basically on how the software communicates with the. So, for example, if I log in using maybe genuine credentials, what happens? If I log in using the invalid credentials, what happens? How software communicates with it. Okay, yes. In this case, actually, I recommend that you can use the to their system. But of course, we have very many, platforms or tools that you can use while coming up with the DFDs, the diagrams, all the elements to get someone who is not, I don't know what is wrong with some people. Then, sorry, I had to mute you because we're getting some bit of noise from the end. Yeah. So I was telling you that we have software design models, and then was telling about the interface design, which you have to as well undertake. And this one focuses on how the software, of course, communicates with itself, first of all, then with the system that share data with it. For example, now in case your system is maybe having maybe a wallet, maybe it has a payment kind of function, whereby now you have to integrate other systems through their APIs. For example, maybe people have to pay maybe for online registration or online application through mobile money or through bank. So the systems that share information with it. So all of this is described in the interface design, and of course, even how people are going to do what to interact with the system you get. So data and control flow diagrams provide much of the information required for interface design. Yeah. Then we have the component level design, which is created by transforming the structural elements which were defined by the software architecture now into the procedural description of the software step by step. Yeah. So these components use information obtained, of course, from the analysis model, and then, of course, even the flow-oriented elements as well as the behavioral elements in this case. So, what I want you to as well understand is the only way you can, of course, accurately translate the customer requirements into the finished software product is to come up with a design. So it serves a foundation for all software engineering activities. Without this stage for the design, then it becomes very, very difficult to, first of all, assess the risks that you may come across while coming up with a project or while the project is out of use. Excuse me. Yeah, sometimes it also becomes very difficult to assess what test you get, as well as whether your product meets the quality that was intended by the users. So in order to mitigate all of these, you get and achieve a better rate for the three attributes, it is better that you pay much attention to what? Much attention to design. Yeah. Okay, this is of course just a recommendation. Yeah, software design can be regarded as a process or a model whereby design process is a sequence of steps that enable the design, of course, to describe all the aspects, of course, of the system to be what? To be built. But when it comes to a model, of course, it is equivalent to an architect's plan for a house. You get the way how you can, of course, demarcate. We are going to have this from here. Allow me to. Okay. Sorry that Josephine says my voice is down. Sorry for that. And let me try to improve a bit, though I'm not doing well, but let me try my level best so that you are able to hear. Yeah. We have principles that govern software design, and what we need to know is that designers should consider alternative approaches. Yes, every time you embark on what? On designing a software product, you have to consider alternative what? Approaches. And you have also to be traceable to the analysis module, meaning that a single element of the design model is always openly traced to multiple requirements. These are just recommendations that you can go through. And then when we talk about an architecture, yes, maybe at an advanced level, you will be, of course, reading what we call enterprise architecture. But now, for this matter, we only focus on software architecture, which is the structure of a system, which comprise elements, first of all elements, their external visible properties and the relationship among them. Meaning that here you look at the system itself, then you don't limit the scope to only the system, but also the external kind of associated components where we have the users, where we have other systems that are going to share information with the system. Then the relationship among all of those, both the internal and the what? The external. That is the software architecture focus. You get. So the architecture design is the design process for, of course, identifying the subsystem making up a system and the framework, the subsystem control and what? And communication. As you can go through. I wanted us to these ones advantages you can read, and I believe you will understand. Structure use. Okay, structure use. Okay, we talked about this in our first that was in the requirement specification, where we talked about the non-functional system requirements, where you have the performance, speed, security, safety, availability, maintainability. These are not all those are non-functional system requirements. Yeah, we have, okay, like maybe just to give you a reminder, a recap. For example, on this non-functional system requirement of performance, where you have to localize critical operations and minimize communications. Yes. So the components all deployed on the same computer rather than distributed across the network. Use a layered architecture with the critical assets protected in innermost layers. Yes, you can just add different layers depending on what the system does and then what security level is required for this case. Safety designed to, there is a difference between security and safety. So I don't know if maybe you have done this in information security before. Then we have availability, meaning that it has to always be accessed by defined users at all times. These are just the architecture views, which are also very important. Like they are in form of questions. What views or perspectives are useful when designing and documenting a system architecture? What notations should be used for describing architecture models? We have quite a number of them. You perceive it in different ways. That is the logical view, the process view, development view, physical, and so on. Then we have them well elaborated here. Now, for example, the physical view, it shows the system hardware and software components. Okay. So when you talk of the logical view, it shows the key abstractions in the system as objects or object classes and how they relate to each other. Okay. We have data-centered architectures. All these are on architectures where we have our data store, where data is, of course, what we can consider to be like our repository, where we have client software, we have quite a number of them, all pointing, fetching, and submitting to our data stores, whereby this repository is always the center of all the data that is related to that particular system. It is, of course, accessed frequently by other components that can be able to, of course, carry out game wells. You get where we have the update, you can add, you can delete, and so on. So those modifications, the syntax architectural advantages are also here that you can just go through. Yeah, whereby they are clear. Then we have the client server architecture. Client server architecture, you must have read this as well in networking before, where you have client machines working with the server machines, and the use of clients is always to, of course, send it, and then the use of servers is to respond to those what? To those requests. Yeah, so a very good example is the internet. So data keeps in and out, that is from both sides. So the functionality of the system is organized into services, whereby each service derived from a separate what? A separate server. And you realize that these clients are users of these services you get. And a system that follows the client sub partner is always taken to be a set of standalone servers which provide specific services like printing, data management, and so on. So there are some of the advantages and disadvantages. And then we have the layered architecture, as well as, let me see something small that I had. Check. I think we can as well look at software testing. Yeah. This one, at least, yes, in our previous engagements, we have talked about it. Yeah, during some people's submissions. Yeah, software implementation, of course, also comes with what? Challenges. Yeah, whereby there is a lot of code reuse, version management, target cost. So code reuse, whereby you realize that the huge issues faced by programmers for compatibility checks and deciding how much code to reuse. You get versioning every time any software is issued to the customer. Developers have to maintain the previous one, and of course configure related documentation. This documentation needs to be highly accurate and available on time. Those who are interested in coding, documentation is very, very important. It helps both you and the other developers to use your code at any time with ease. You get, yeah, that is in place. The documentation is in place. It is one of the good practices of implementing what software. So the software program which is being developed in the organization needs to be designed for host machines at the customer end. Those are some of the implementation challenges. and what do we target while we are carrying out software tests? What is our major target? Yeah, in most cases, we are basically looking at to reveal, like to discover faults. Yeah, what could be not right with this system? Because you know very well, some systems are very sensitive, meaning that once tests are not well done, it can either lead to great losses to company. For example, if it is a financial bureau system, like a money remittance system, you know, people can easily, you know, like break into it and then make great losses to the company. If not that, then it can even lead to loss of life, because now just imagine the system you build is a life support kind of system whereby it can easily detect that maybe, you know, it can sense, you know, that maybe power is going to go off. Let the alternative source be on standby, whereby there is no latency at any moment, meaning that once tests are not well done and probably maybe power does not switch to support the life supporting machines or devices, then people are most likely to die out of, you know, the gaps in your system. So sometimes, yes, we also target to have confidence, you know, something that you have tested again and again. There is a way how it instills confidence in the users, you know. So there is clarity. I mean, we also look at clarifying the specifications, whether it is as intended, you get. Yeah, another target is to represent the customer, of course, contract. Yeah, this is something very, very important also, that necessitates the what? The testing. Yeah, but the only major limitation in this is that it can only show the presence of errors, not their what? Not their absence. Yes. So then this one, very many members before have even made submissions about it. Yeah, when we were trying to discuss what testing could be. Yeah, and yes, this definition is in line with what has been discussed before. Testing in most cases is just a step by step that you have to take to execute a program with the intentions of finding the issues in this kind of system. So you realize that testing shows that a program does what it is intended to do, and it discover program defects before it puts into use. Yeah. So because it becomes very, very easy to manage an error during development than managing an error when the system is already on market. You get. Now just imagine maybe mobile money for MTN has errors and maybe they have to rectify when the system is already in use. Meaning that, you know, yes, it can lead to great what? Great losses. So when you test the software, you execute a program using, of course, artificial data. Testing can reveal the presence of errors, not their what? Not their absence, like said before. Yeah, people make errors. A good synonym is mistake, of course. This may be a syntax error, or of course, sometimes a misunderstanding of what. Yeah, sometimes you can misinterpret. Let me show you a brief diagram here that I want to share with you briefly. Let me show you something small here. Let me show you. Check here. Let me check. Okay. I always share this in my sessions. I must have shared it before. Okay, let me share this briefly and see what happens. I guess you people are able to see my screen. This is then on my profile, if I think, yeah, whereby now you realize that once there is misinterpretation, misunderstanding of the customer requirements, what the customer needs by the team, okay, from the team, then you most likely, now just look at the first picture here. You realize that a customer wants this kind of swing. You get that, you know, yes, of course, there is a tree that provides a shade, and then there is a branch where this swing is what is tied with the two kind of can I call them handles, you get. Now, but this is what is in the customer's mind, that at the end of the day, this is what he or she expects, you get. Let me check this one. Check this one. Find it easily. No, it may take us time, yet we have less time. I wanted it to review a better one, but we can use this. I will share the better one in the slides, yeah, as well as on our model. Yeah, like I've already told you, explained, this is what a customer is expecting, you get, at the end of the what? Of the project. Yeah. Then I request members to mute, please. Yeah. What I was saying is that this is what is in his expectations. But now when the customer starts explaining it to the team of developers, this is what the customer explains it. It takes us back to the point of misunderstanding of customer requirements. And trust me, once you don't run the tests, then at the end of the day, we are going to have such outputs, which not in any way in line with what we are supposed to do. So this is how the customer has explained to the team, whereby now I don't know where the second handle has gone, as well as where they sit and so on, you get. So this is how he or she has explained it. Now, when it comes to the project manager or the head of that project, this is how he or she interprets it, that maybe this person wants a handle from one branch, another handle from another branch, a stem is in the middle, then this kind of where they sit is of this format, you get. So, and now when it is taken into the design stage, or where a systems analyst has to work on it, for him, he interprets it in a way that when someone is like using it, it must go through the what? Go through the stem, something which is actually even weird, you get. But according to the design that has been made, this is what has been come up with. Then when it comes now to the developers, based on the design that they have gotten from the systems analyst, they are going to, for them, according to them, you see that they also now go and come up with something which is somehow similar from what a customer expects. But now I don't know where they got the three what? The three steps you get. Yeah, and then this component where they sit is also not, of course, the same as the expected one. Then when it reaches the testing level, you see what happens. Yes, when it reaches the testing level, that is where all goes in a mess by collapsing. You get. And once this has been tested and the swing is down on the ground, tied to the
It's 9 o'clock.
tied to main stem, you realize that this kind of project cannot be of any use really. And then when the team goes on, insists and goes on to install it, they install it just on one branch, and this time round, this is how maybe it is even as if someone is preparing to commit suicide using a project you get. So then when you give it to your team, to go and start working on it. That is how the business consultant describes it to other stakeholders. They try to spice, and this is what is now being put in the minds of other what stakeholders. And then your marketing team goes on telling people, you know what, we have a project that has two things which is somehow also similar to the what, which is similar to what is expected in the market, only that this time around this sitting plate changes, and then when it is delivered, this is what is being put on ground. You get. So how the project was documented, so you realize that all of this is in a mess, how it was supported during maintenance, how the customer was billed, the customer was charged the money that it could do, be used to come up with that kind of, way. Then the disaster recovery plan is also in this mess, how it is performed, how it performed under load, how it has broken down, how it is performed under overload, it just collapses. What happened after discussion? Then we'll see what is now happening. What the customer really needed was this. This was what was expected, but what according to all factors put into consideration, this was what was supposed to be put in place. Now, I want each individual at least to go and yes, I'm going to upload this our model, and what I just need from you is basically to give a few lines of what do you think, where the problem came from, where the major problem came from. Yeah, I just want you actually to pick one, yes, one or two of these where you think the problem might have originated from, and then the next kind of maybe paragraph can be on how best to avoid this. Yeah, so that is what I'm expecting from you. Then see. Okay. When developers make mistakes while coding, we call these mistakes. Of course, yeah, these are bugs. A fault is the okay. These are all testing terminologies. Yeah, that of course, which I think you already aware of. So um, then we have a failure, we have an error, we have a fault. So basing on what you see here, what do you think this is? Is it a failure? Is it an error? Is it a fault? We need to describe specified and desired behavior first. So we have what we call the fault handling techniques. How do you handle a fault in a system? Yes. First of all, the best techniques that we have to employ while coming up with the systems is to put all what we can in place to avoid the fault from happening on a what? On a system. That is fault avoidance is one technique that you have to do what? To employ. So then if that is in place, or in case it fails, that you realize that okay, sometimes you may not have guarantee, but at least ensure that you have tried or to ensure that the system can avoid. For example, we can do this through validations. For example, in a case, maybe we have a form on our system where people have to enter their phone numbers, then of course we can validate and make this data type integer, whereby it does not allow any string to be entered in this case, and other things you get. So we are trying to avoid faults from happening on our system. Yeah, population management. Then another technique that we can employ is to detect the moment a fault happens on a system should have the ability to instantly detect by alarming you that something wrong has happened. So your system should have the ability to detect faults every time they happen on a system. That is what most companies use. You get that is why sometimes you receive messages from big telecom companies telling you that maybe at a certain point, at a certain time, maybe our services, mobile money are going to be down due to maybe maintenance, blah, blah, because the system has detected some faults that they have to fix. Then sometimes there are faults that are hard to deal with, whereby you just need to tolerate them and work on minimizing the effects that they can come with. You get, yeah. For example, now if you're using internet, trust me, you are vulnerable to viruses. You get, and of course hacks and so on. Every time you're on internet, or generally the network, yes. So meaning that you can decide to tolerate such faults, yeah, whereby, yeah, in this case we can have atomic transactions, modular redundancies, and so on. So here we realize that in detecting faults, we do the testing and then debug. You get, yeah, we can debug, so that we keep, once you debug, you have to test again, debug and test again. Yeah. How do we test? Is we have three major kind of testings that are testing, as you hear the word unit testing, meaning that the system is broken into small manageable modules, whereby now once you are test, you test module by module. But sometimes even some modules are big, whereby you don't need to test the entire module, but rather you test what we call function by function. If a certain module has things like maybe authentication, then we can test the authentication. If it has something like maybe, data retrieval, then we'll test that. That is under unit what? Under unit testing, we can carry out again what we call the function testing. You get. Then we have what we call integration testing, meaning that of course once our system is big, it has quite a number of modules. How does my module relate with other modules on the same system? How does my system interrelate with other systems outside our system, but we share data?
Excuse me, sir.
A moment, please.
Excuse me, sir.
Moment.
Volume is too low.
Let me check. Yeah, sister, you can please go on. Hello. Sis, was this? I remember, but please, you had something to say. Hello. I remember, but Santrina, you had something to say. I don't know whether I've lost her, but I see she's on, but she's not saying anything. I don't know if you can hear me. Just a moment. Members, sorry for the interruption. Very sorry for that. Someone had a question, maybe before we can proceed, but I was telling you that yes, we can do the testing in various ways. We have what we call the unit testing, which looks at a small unit of the system you get, which can be in the form of a module. And sometimes you have to go beyond even a module and the test functions of a module you get. Yeah, in case you are to find proper functionality of a particular system, then we have what we call, actually, you're going to use all these, yeah, in your final year project. So meaning that yes, even when you go to the panel, you're defending your work, yes, you are able to know which kind of testing did you use. Was it unit testing? If it was unit testing, how did you do it? You get, that is why I've told you for unit testing, yes, it does not test a system as a whole, but rather the different components in a system that you're looking out test you get. Yeah, these can be modules like authentication module, it can be registration. Sorry, registration is part of authentication, but it can be maybe payment, it can be, quite a number of them. Then we have integration testing, like I've told you, how does your module relate with other modules of the same system? How does your system again also relate with other systems that it shares data and information with? Then when we talk about system testing, here we look at testing a system as a whole. Again, yeah, the entire system. I would not recommend this whereby sometimes it is not effective. Yeah, as if the way how you can. Let me give you an example. When you are scanning for viruses in your computer, sometimes you realize that once you do full scan of an entire system, there are some bugs. Sorry, there are some viruses that can be hidden and skipped. But when you go and scan, like maybe partition by partition, chances are high that the scanning is going to be more and more effective compared to the entire the entire system. Let me see. Okay, these are also testing principles that you can read, and I guess you will understand. Like, it is important to understand these principles. Okay, testing should be planned long before testing begins. Yeah, just these are recommendations, and these are some of the good attributes of testing. And yes, of course, this one is expected that yes, when you're running tests, expected to find the things that are not working as expected. So tester must understand the software and attempt to develop mental picture on how the software might fail. Yeah, the test is not redundant. These ones you can read and I guess you will understand. The test should be best of breed. A good test should be neither too simple or not too complex. Design for testing, ensure components can be tested in isolation, yes, which minimizes dependencies on other components. That is basically fits for unit testing, and it provides constructors to set up objects for testing. And when you are done, when are you done with the testing? When can you say that, okay, fine, I've now accomplished what? Testing bit. When that is most run out of time or money, and try to use statistical models. These are only as good as your localization of the inputs, which is often quite bad. So these are just attributes of testing quality, where we have throughput, we have reliability, and so on. This you can go through, you can understand. Yeah, which we have talked about there quite some time. Test the plan, which strategies do you need? Unity, is it functional? Unit testing, I've already talked about this. Integration testing, system testing, acceptance testing. It evaluates the system delivered by the developers. It is also carried out by clients. Yeah, because you, after carrying out your tests, then the people who are going to use the system must also do what? Run their own tests. That is acceptance testing. So I believe the rest in this slide you can go through what you don't, once you don't understand, then we can always do what? These are just the cases and the mathematical testing tools that I entered that you can use. But what we are going to do is I intended to terminate the session from here because you don't get anything. You can always add it in what? Add it in comment section actually. But for the other picture, I'm going to add it as a simple assignment where every person has to put some bit of what? Participation by putting simple write-up on what might have gone wrong, where and when. So it will help us a lot. So allow me to terminate our session for today, unless maybe someone has a small question or any comment or anything that is worth sharing. Anything?
Mr. Olubo. Mr. Olubo. Hello.
That then allow me to terminate and then we'll call it a day.
Well,
Thank you.